Okay, this is section 2.3 in Math Links 8 on ratio, rate, and proportional reasoning. This is our last section. So 2.1 was on ratios, 2.2 was on rates, and this section 2.3 is utilizing proportional reasoning to solve a proportion or equivalent ratios or rates. That's what a proportion is. So our first one says 3 dinner rolls cost 99 cents. Determine the unit rate. So if we put down what our units could be, it could be cost per roll, or it could be rolls per dollar. And both of those rates we could make into a unit rate, meaning we could get how much roll can you get for $1, or how much would it cost for one roll. Given the fact that both are unit rates, the one that's most appropriate would be this one, and therefore the cost is 99 cents, which we're going to write as 99 hundredths of a dollar, or 99% of a dollar, or 0.99 hundredths of a dollar for 3 rolls. Yes, I am. Equals how much for one? Given the fact that we can choose different methods, the one I'm going to use is simply dividing both by 3. And therefore, I have determined that the cost per roll is 33 cents per roll. And when we make a unit rate and we change it to per, our line becomes a slanted line and our 1 disappears and we just say per roll. Okay? And in B, it says 7 identical objects have a mass of 14 kilograms. So do I want to know the mass per object or the number of objects per kilogram? Obviously, I want to know the weight per object. So I'm going to put weight. And I'm going to put object to orientate my terms. I have 14 kilograms for 7 doodads. And therefore, if I make a unit rate per 1, I divide both by 7. And I get 2 kilograms per doodad, or 2 kilograms per object. That would be the unit rate. Question 5 is no longer existing. I don't know where it went. It's disappeared into space. But it says, Delia was paid $35 for 5 hours of babysitting. How much did she receive for 3 hours? So right here, we have enough information to create what from that yellow highlighted? I can create a rate. And that rate is $35 for 5 hours. Now, if I put an equal sign between them, that means I am creating what we call a proportion, meaning an equivalent rate to another rate, and in this case, per 3 hours. Okay? Now, given the fact that we've learned 3 different methods, we could use a unit rate, we could use a multiplication or division statement to create equivalency, or we can use the algebraic method. All 3 are afforded to us. However, this question says to use our unit rate. So what we're going to do is we're going to erase this part, and we're going to put it over here. And in between them, I'm going to put a unit rate of 1 hour. That's a 1. It looks, well, let's change it because it doesn't look like a 1. Now it looks like a 1. There we go, 1 hour. And to get that, we're simply going to divide both of our terms in our original rate by 5 to create a unit rate of $7 per hour. Now this is what we would call a proportion, right? And a proportion by definition is simply 2 rates or ratios that are equivalent to each other, right? And because that's true, we can then use that information to create another proportion. If it's $7 for 1 hour, how much is it for 3? We can multiply both terms in our rate by 3, and we would figure out that it's $21 for 3 hours of work. Question 8 says determine the missing value. It does not give us instructions for what method to use. So what I'm going to do here is I'm going to create 3 different methods, one for each of the 4 different things. Now typically, the most appropriate method for this would be to say, well, I multiplied this by 5 to get 15. So I would multiply this to get 10, and that would be solving it. And that's using multiplication division to solve your missing values in a proportion. Now in the second question, B, I could do it one of 2 ways. I could say I divided 35 by 7 to get 5. So I could divide 14 by 7 to get 2, and the answer would be 2. But we're going to try a different way. We're going to try the algebraic method. So if I treat that missing value as x and multiply across the equal sign, I can create an algebraic expression of 35x. Then I will put my equal side, and then I will multiply across the other way to get 70. And once I do that, I can divide both sides by the coefficient of 35, and x would equal 2. So we could figure it out that way. So that's a different way we could solve it. Instead of the multiply divide, we can use the algebraic method. And actually, we should have used a different one for this one because now I can't use a unit rate for this. Well, I suppose I could. So if it's 30 for 45, and I want to determine how much it is for 1, I would divide both by 30, and 45 divided by 30 is 1.5. And if it's 1.5, 1 to 1.5, then per 6, I would simply have to take my 1.5 and multiply it by 6, and I would get the answer of 9 as a solution. That's using kind of like an inverse unit rate. If I wanted to think of it this way, I divided this by 5 to get 6. And if I divided that by 5, I can get 9. That's using the multiply and divide method as well. And finally over here, since I know both of my terms in this ratio or rate, whatever it happens to be, I divide 12 by 4 to get 3. So therefore, to keep it proportional, or if you want to use the word equivalent, proportional is a better one, you can divide both terms in your rate or ratio by 4, and you would solve it by getting 9 is your missing value. Question 9 says determine the missing value to make each rate equivalent. Include the units. So we don't have to use any particular method, right? How many of you used the algebraic method for all of them? How many use multiply and divide for all of them? How many of you use unit rate for all of them? Okay, we all use different ones. I'm going to use a different one for each. So here, I'm going to use the multiplication method. So since I know both 60 and 3, I know I multiplied 3 hours by 2 to get 6 hours. So I have to multiply the top, and I would get 120 kilometers. So therefore, my rate would be 120 kilometers per 6 hours. That's a rate, not a unit rate because it's not per hour. It's per 6 hours. Over here, if I wanted to solve this one, even though I would use multiplication because I know that this would work, right? I know that that's going to work, and I know my answer is going to be 20. I'm pretending I didn't know that, didn't see that. I can multiply across here to get 3x, multiply across here to get 60, divide both sides by 3, and x would equal 20. In question C, I think probably division is easiest, again, isn't it? If I divide this by 2, I get 1 minute. Divide this by 2, I get 50, 35, 85. 85 and 4 is 89. So I get 89 beats. Now because it's per 1 minute, I can put the per down, drop the 1, and just say 89 beats per minute, because that technically is a unit rate, because we have per 1 minute. And the last one is a great example of I have absolutely no idea 48 times what is 192. I have a good idea. I'm pretty sure it's what? I'm pretty sure it's 4. But let's pretend we didn't know. So obviously, the easiest way for me to do this is say, well, hold on, if it's 48 kilometers for $16, let's figure out how far I can go for $1. And this would be called a unit rate. Divide both by 16. That means I'm going 3 kilometers for every dollar. That didn't help me at all, did it? Because now I have an even bigger problem. I go 3 times what is 192. Well, that didn't help me. Well, I'm just trying to show you different ways to solve it. That's what the... All right, let's solve it algebraically. What would my algebraic equation be if I'm solving it? 48x is equal to the product of 192 and 16. I know. 192 times 16 is a big number. And then I'm going to divide 3072 by 48 to get my answer. So take this number, hit the divided by into the 48, and it tells me that x is equal to 64. Now, if I knew that because this, of course, 48 times 4 is 192, and 16 times 4 is 64, I could have solved it much easier that way. But either way you did it, you got the right answer. Question 10. Question 10a says if 10 beans have a mass of 17 grams and 30 beans have a mass of 50, it just says set up a proportion. So the first rate is 17 beans, or sorry, 10 beans for 17 grams is proportional to 30 beans to 51 grams. So all we did was we put, and you could have had 17 grams to 10 is equal to 51 over 30. Both would be fine. That's just the one I did. That's all you have to do. You don't have to solve these, you have to set it up. So for boys to girls, I'm going to first put down my letters to make sure I put the right numbers in the right places. 13 boys to 15 girls is proportional to 65 to 75. That's my answer for the second one. And for the third one, centimeters to kilometers. 1 centimeter represents 25 kilometers on a map. So therefore, 6.4 centimeters on a map will equal 160 kilometers. There's my proportions. Question 11 says a small gear turns 18 times in the same time that a large gear turns 4 times. So how many times will the large gear turn if a small gear turns 54 times? It says draw a diagram to help set up the proportion. Well, I'm not going to draw a diagram, but I am going to say that I need to determine small and large. I'm going to put S over L. And the first thing you should have in your paper is what is my first number of my ratio going to represent? So a small gear turns 18 times and the large gear will turn 4. That 18 to 4 is a ratio, not a rate, because it's comparing the turning of gears. Now, once I say this ratio is equal to another ratio, I am setting up a proportion, right? And it says a small gear will turn 54 times. How many times, or X, will that large gear turn? 3 methods to solve: multiplication, division, unit rate, or cross multiplication. In this particular question, what appears to be the easiest way to solve it? Maybe. Does anyone know what 18 times 3 is? 18 times 3 is 24. 3 18s is 24. 3 18s is 54. So if you know that, then this, of course, proved to be the easiest method, because then you say, therefore, the large gear will turn 12 times. But if you didn't know that, then what you probably said was, okay, I have a unit rate or I have cross multiplication. I'm going to use the cross multiplication. 18x is equal to 216. I'm simply going to divide both sides by 18. So 216 divided by 18. What answer did we say it was again? What should this be? Yeah, and it is 12. So x will equal 12. Okay? So either way, you solve the proportion using either multiplication division or cross multiplication for algebra. You could technically make it a unit rate, right? If it's 18 times in 4, then how many times did it turn in 1, and et cetera, et cetera. But this is the 2 methods that would work best. Question 12. So set up a proportion for each situation using a variable. So just like we did in the last one. Walter makes his own oil and vinegar dressing. His recipe calls for 175 mils of olive oil and 50 mils of vinegar. What amount of vinegar does he need for 300? So the first thing I'm going to do is write down what unit is going to go where. So I'm going to put an O for my top unit and a V for my bottom. And you might have V over O, it doesn't matter. As long as you structure it so that when you put your ingredients in, you don't screw it up. So it's 175 mils of olive oil, so 175 goes up top. It's 50 mils of vinegar, that goes in the bottom. That is our ratio of oil to vinegar. And the proportional amount is going to have 300 mils of olive oil. And I don't know how much vinegar. Now let me ask you a question. Does the multiplication division method work best for this one? No, because 175 times something, there is no whole number that will multiply by 175 to get 300. So it's going to be a decimal. So even though it's not impossible to do it that way, it might not be our easiest method. So here, because we use a variable, we're going to use that equation. And our equation will be 175x is equal to, well, 3 times 5 is 15 plus 3 zeros is to 15 plus 3 zeros, or 15,000. Now that we have that, to isolate for x, I will do what? Take your 15,000 and divide it by 175. Good. And you'll get, snapping Archibald, a big long decimal. X is approximately equal to, I'm going to use my thing, 80, what was it again? 85.7. 85.7 mils. So how much vinegar would you need? Approximately 85.7. If you said 86, that's fine, right? 86-ish. The second part says a baseball player has a home run to strikeout ratio. And as soon as I read that, I'm like, okay, I'm going to write that down. It's a ratio of home runs to strikeouts. It's a ratio, not a rate, but a ratio. And it says that the ratio is 3 to 17, or 3 home runs for every 17 strikeouts. How many home runs? Now, as soon as I read that, how many home runs? If I stop right there, what do I know so far? How many home runs? That in my ratio, which one do I not know? Home runs. And what's that going to be allocated? It's going to be given the variable X. How many home runs if he strikes out 187 times? Now, for some people, the algebraic method might not be the easiest for this, because some people are going, hang on, 17 times 10 is 170. What would 17 times 11 be? If 17 times 10 is 170, what's 17 times 11? 17 more than 170, which is what? 187. So you might do this and figure out that the number of home runs he would hit would be 33, right? That would be a way to do it. But since I'm sure most of you didn't know that, you probably did this. 17x is equivalent to, I can't do this without a calculator, 187 times 3. My brain's not bright enough. 561. And of course, what would I do next? Divide that 561 by the coefficient of 17, and I would isolate it down to x equals 33. Question 13 says 2 quarters have the same value as 10 nickels. So quarters to nickels. Nickels, of course, are 5-cent pieces. Quarters are 25-cent pieces. So 2 quarters has a value of 10 nickels. That's proportional to 5 quarters is equal to how many nickels? What would my algebraic equation be, real quick? Go for it, Aubrey. What is it? Real quick. 2x equals 50 is correct. And if that's my equation, Ty, what would be my x value then? 25. X would equal 25. So therefore 25 quarters, or sorry, 5 quarters is equal to 25 nickels. I think we all knew that to begin with. I didn't think we needed algebra to solve how many nickels are 5 quarters worth, but that's how you set it up. Question 14, the rate of snowfall was 30 centimeters fell in 6 hours. If it continues snowing at the same rate, how long will it take for 45 centimeters to fall? So I'm going to set it up as centimeters to hours, or 30 centimeters to 6 hours. That's the original rate that was given to us. How long will it take? How long will it take means I do not know the time. It's going to become h if 45 falls. Does anyone in this room know what you multiply 30 by to get 45? 1.5. Now, if you knew that, you multiply 60 by 1.5 and 6 by 1.5, and you solve the question 9 hours. Because 6 times 1.5 is 9. But if you didn't know that, the easiest way to solve it, let's do it this way. Let's do it another way where it's not multiplication. I'm going to figure out how much snow falls in 1 hour. How much snow would fall in 1 hour? 5 centimeters. So how long would it take for 45 centimeters to fall? 9 hours. That's breaking it down using a unit rate, right? We could do that. But most of us said, you know what? I just really like this. 35x equals 240 plus 270. Divide by the coefficient. And x equals 90. Therefore, sorry, 9, not 90. 9. Yeah, well. Question 15 says, look at the pattern. Set up a proportion you could find to find the number of squares in figure 1. So if I set it up like this, now watch this, figure number and number of squares. This is wild stuff. Figure number 1 has 2 squares. Figure number 2 has 4 squares. Is there a proportionality between figure number and number of squares? Are they proportionate? The number of the figure and the squares that they contain? Yeah. And then figure 3 has 6 squares. Are they proportionate? Yes, they are. They're all, the figure number is half as much as the number of squares. So therefore, if I take this original figure and say figure number 7 will have how many squares? How many would it be? It'd be 14 squares. I could solve it with multiplication. I could solve it with cross multiplication. I could solve it with unit rate. That's true. That's a pretty easy question. Question 16 says, a gardener takes half an hour to mow and weed a lawn that measures 20 meters by 15 meters. He charges 25 bucks an hour. How much should the gardener receive for a lawn that measures this? This is a tricky question because it asks you, do you know what your rate terms are going to be? So your first term is going to be time, and your second term is going to be what? It's going to be area. Area. So for the first line, half an hour is going to be 0.5 hours. You could use 30 minutes if you want. I'm going to use 0.5 hours to represent half an hour. What was the area of that lawn? Well, the lawn, if it was a picture, the lawn was 20 by 15, so the lawn was 300 square meters, right? So it took him half an hour to mow 300 square meters of lawn. Now, if this rate at which he mows the lawn, because that's a rate, is consistent or constant, then how much should he charge? How much time will it take first? How much time will it take to mow this lawn? Well, this lawn is 1,200 square meters. Okay? You with me now? So it takes him a half an hour to mow 300 square meters in the first lawn. How long will it take him to mow the second lawn, which is 40 by 30, and 40 times 30 is 1,200. So obviously the easiest way to do this is to say, well, I'm going to multiply this by 4 and this by 4. And what's a half times 4? 2. So therefore, it will take him 2 hours to mow that lawn. Therefore, it will take 2 hours. And, put a comma there, and it will cost, since each one is $25 per hour, it will charge $50. It will cost $50 to mow that lawn. That's not a bad rate, 25 bucks an hour. This textbook's old. That's not a bad job to have. If you can make 25 bucks an hour mowing lawns, you do 8 hours of lawn mowing, how much money is that? 200 bucks. Yeah. And I don't advise you not to pay taxes on it, but if you don't declare it, that's tax-free money, which is illegal, so don't do it. And your last question from your homework has to do with a pickerel, which I did not know what a pickerel was, but apparently it's a fish. Fresh pickerel is advertised at the local market. How much will 6 kilograms of pickerel cost? So right here, what information is given to us? That's called a what? a rate. Now, do I want to do dollars per kilogram or kilograms per dollar? I'm going to put dollars to kilograms to start, and it's 1760 for 2 kilograms. How much will it cost for 6 kilograms? Now that I set up my proportion, what's the easiest of the three methods to use here? Obviously, it's easiest to multiply both of my terms in my original rate by 3 to maintain the proportion. So if I know that 2 kilograms is 1760, then 6 kilograms will be $17.60 tripled, which is $52.80. All right. Now, that's the easy question. The difficult question becomes our next one, B. It says use a proportion to find the cost of 1,600 grams of pickerel. Well, the first thing we need to know is right here, 1 kilogram equals 1,000 grams. So 1,600 grams is equal to how many kilograms? If 1,000 grams is a kilogram, then 1,600 grams is how many kilograms? 1.6. That's the first thing we had to make as a conversion. That's the hardest part, is realizing I had to convert those grams to kilograms to start. So now, if I take this $17.60 for 2 and say how much is it, or X dollars, for 1.6 kilograms, what method makes the most sense for this? Algebraic, multiply, divide, or unit rate? Algebra or unit rate. The multiplier method doesn't seem to be very efficient here, so we're not going to use it. So the algebraic method is going to give me what side? It's going to start off with 2x. The other side will be the product of 1760 and 1.6. 1760 times 1.6, which is 2816. Now, can we do this in our head? Can we do this in our head? If I just put x, can everyone do that in their head? What's half of 2816? $14.08. Okay. Now, just even though we don't have to, I'm going to show you using the unit rate method. If it's 1760 for 2 kilograms, then how much is it for 1? It would be 850 plus 30, 880. It's 880 for 1, and therefore for 1.6, it would be 880 times 1.6, which is the same answer.